1.4, which is factoring and solving quadratic equations. So we're going to take it one step further than our last lesson. Let's take a look at number 4. So we do have to factor, and then once we factor, we need to solve. So here's what I notice is different than the last section, is that I have an equation. I have something that's equal to 0. So in the last section, I had just a trinomial expression that looked just like this. And I had to factor that. So today, we're going to not only factor, but we're going to set the equation equal to 0. So really what we're finding today are our zeros. We also call those the roots, the solutions, the x-intercepts. So today we're going to use the term roots. So when I find the zeros, I'm finding the roots. So to begin, I'm going to factor x squared minus 3x minus 4. Now one way to factor is to use the multiplication table model. But here's another idea that I want to show you. It's called the X box. And the X box can help me to factor something like problem number 4. Number 4 has the number -4 right here, my constant term, and my middle term is -3x. I'm going to put -3. So what I'm looking for is I'm looking for two numbers that multiply to -4. And at the same time, those same two numbers have to add to -3. So I'm thinking of the numbers 4 and 1. Those two multiply to 4, but I need it to multiply to -4. So one of those is going to have to be negative, and it looks like the 4 is going to be negative, so that I get a sum. So when they add together, those two numbers, -4 and +1, add up to -3, but they multiply to -4. So that's going to help me in my factoring. So my two factors are x minus 4. There's the first factor. The second factor is x plus 1. Is my second factor, and that is equal to 0. We're going to apply the zero product property, which basically says if one of these factors is equal to 0, then my equation is equal to 0. The answer is 0. So the question is what number right here would give me the answer 0? So x is equal to 4. 4 minus 4 would be 0. And then what number right here would give me the answer 0? X equals -1. -1 plus 1 is 0. So if either of those are replaced in my original equation, I get the answer 0. You can check that. Replacing x with 4 first, and then going back and replacing each x with -1. You can check your solution, and both of those will give you the answer 0. So real quick, what that means is if I were to graph this, I have two zeros. That's what the roots are we're finding today are the zeros. One is at +4, and the other is at -1. So I have a parabola that's opening up, so it looks something maybe like this. Number 6. What I notice about number 6 is both of these terms, the first term and the second term, have a greatest common factor of x. So I begin by factoring out that greatest common factor, leaving me with x plus 8. So once again, I'm going to apply the zero product property, which says this term could be equal to 0, or this binomial is equal to 0 if x is -8 and if x is equal to 0. Number 8. So what I noticed about number 8 is I just am not liking this -t². I like my t² to be positive. So I'm going to begin this problem by bringing -t² over to the right side. And I'm also going to bring this +12 over to the right side. And I'm going to rewrite this in standard form. -t² to the other side becomes +t². +12 to the other side becomes -12t. +12 32 remains on the right side, and I'm going to set that all equal to 0. So now I'm going to use my X box again. I'm looking for two numbers that multiply to 32, but that add up to negative 12. Two numbers that multiply to 32 are 8 and 4, but they do not add up to negative 12 unless they are both negatives. So my factors are t minus 8, t minus 4. Therefore, my roots are positive 8 and positive 4. To solve number 10, I'm going to use my multiplication table to factor 2t squared plus t minus 3. So I'm thinking of two numbers that multiply to negative 3. I'm going to put negative 3 times 1, and let's see what we get. Negative 3 times t is negative 3t. 2t times 1 is positive 2t. And when I add these two together, I get negative t. Fortunately, I need positive t. So I'm going to go back and adjust by changing this to a positive 3, which gives me a positive 3t. Make this a negative 1, which gives me a negative 2t. And now I have positive 1t. So my factors, 2t plus 3, t minus 1. And all of that is equal to 0. Now it's very clear to see that the root for this portion of the equation is t is equal to 1. This one we need to think a little bit more about. So the question is what number for t would make all of this equal to 0? What number t would give me an answer of 0? So I'm going to subtract 3 from both sides, gives me negative 3. And then I'm going to divide by 2. So negative 3 halves is my second root. And number 12 gives me a function, and they want me to find the zeros or the x-intercepts. So to do that, I'm going to exchange f of x for 0 equals x squared minus 5x. And I'm going to solve this algebraically to find my roots, which would then give me my zeros. So I notice both terms have a greatest common factor of x. And when I divide out an x from each term, I have x minus 5. So one of my roots is x is equal to 0. My second root is x is equal to 5. So the zeros are x equals 0 and x equals 5. As x-intercepts, they would be 0, 0, and 5, 0. So if I were to look at this function, if I were to graph this function, it would look something like this. There's one x-intercept at 0, 0. There's my second x-intercept at 5, 0. My parabola would open up. I'm going to go all the way down to number 18. You see some of the previous problems are very similar, but I'd like to do number 18 because I'm going to go back to using my multiplication table again to help me to factor. And so I'm going to begin with 3x squared and negative 14. So I need 3x times x. And one of my choices for negative 14 is negative 7 and positive 2. So negative 7 times x, negative 7x, 3x times 2 is 6x. When I add these two together, I get negative 1x. Fortunately, I need positive 19. So I don't see these two numbers as being very helpful. I'm going to try and switch them around. Let's try putting 2 here and 7 here. And for now, I'm going to ignore the negative sign and just see what values I can get by multiplying 2 times x. I get 2x. And 3x times 7 is 21x. And I notice that I can take these two terms and get those to be a positive 19 if this term is positive and the 2x is negative. That would give me a positive 19x. So that means my 2 needs to be negative and my 7 needs to be positive. So it looks like my factors are 3x minus 2 and x plus 7. And again, I'm going to exchange and swap out f of x for equals to 0. So I'm finding my roots. Very easy to see that x is going to be negative 7. And here, let's see, I'm looking for what would make this equal 0. So adding 2 to both sides, dividing by 3, gives me 2/3. Number 20, let's begin with the range. The range is the lowest to the highest, from the lowest to the highest. So my lowest y value is 2, and so my range is y is greater than or equal to positive 2. 2 is as low as it goes, and it goes into infinity in a positive direction along the y-axis. For my domain, I have all real numbers. My interval of increase, so let's take a look here. I'm increasing from 2 to infinity. And I just want to remind myself, interval of increase and decrease is along the x-axis. It's in terms of the domain. My interval of decrease is from negative infinity up to, but not including 2. Okay, so we're going to switch and think about subtraction. We've been doing a lot of multiplying. So we want to subtract these two trinomials. So the first thing I want to do is to distribute my negative with each term in the second set of parentheses. And so I'm going to rewrite this as 3x to the 4th plus 3x squared minus 3. The next term would be negative 6x to the 5th. My next term is positive 9x to the 3rd. And the last term is negative 2. In standard form, from descending order, we begin with negative 6x to the 5th, positive 3x to the 4th, positive 9x to the 3rd, plus 3x squared, and then I'm going to add negative 3 and negative 2 to get negative 5. And finally, number 24, to factor this trinomial, I'm going to first begin by taking out the greatest common factor, which is 2. Looking for two numbers that multiply to negative 21 and add up to positive 4. Negative 7